This video also continues dispersion for scale variables. Specifically, this video talks about dispersion around the mean, and you should focus on variance and standard deviation. I will go over other methods of finding dispersion around the mean, but you should focus on these two, and the one you should focus on the most is the standard deviation. Now I'm going to talk about the steps to calculate a population variance. This is only for a population, so you'd have to have all the data that you're interested in. So you have to have the data for your whole population to use this particular formula. On another slide, I will talk about how to calculate sample variance when you only have a small sample out of your whole population. There's a slight difference. The first step to find the population variance is to find the population mean. And we're going to use the symbol mu that looks like a squiggly M for population mean. Second step is to find the deviations from the mean. So you're going to take each of your values and subtract off the mean. So you're going to have as many deviations as you have values. Step 3 is to square every deviation. So you're going to take whatever you get in step 2, all those values, and square them. Step 4 is to find the sum of the squares. And you're going to do that by just adding all the square deviations from step 3. And then step 5, you're going to divide the sum of squares by the population size. And that's your formula for population variance. We're going to use the symbol sigma squared here for population variance. So now I'm going to go over how to calculate the population variance. This example is for the population, not for the sample. When you do sample variance, it's slightly different, and I'll go over that in a little bit. But you want to make sure when you do it this way that it's for the population, not for the sample. So a population is when you have everyone that you're interested in, not just a small sample from your population. So just keep that in mind when you do population variance and instead of doing the sample variance, okay? So the first step is to find the population mean, and then you're going to get the sum of all these values. So if you add all those values up, you'll get 30. And then there's 6 of those values if you count them up. And so you take 30 divided by 6 to get the population mean. So the population mean mu equals 5. The second step is to find the deviations from the mean. So you take each individual value and subtract off the mean. So for example, the first one is 3. You subtract 5, the mean, and you get negative 2. You do 2 minus 5, you get negative 3. 4 minus 5, negative 1. 5 minus 5 equals 0. 8 minus 5 equals 3. 8 minus 5 again equals 3. Now you do not want to sum those deviations up. Remember, it'll just even out to 0. Instead, we're going to go to step 3 and square every deviation, get rid of those negatives. So we're going to do negative 2 squared, that equals 4. Negative 3 squared equals 9. Negative 1 squared equals 1. 0 squared equals 0. And 3 squared equals 9. And again, 3 squared equals 9. Then you're going to go to step 4 and find the sum of squares. To find the sum of squares, you're just going to take that squares column and add them up. And if you add them up, it'll equal 32. And then you're going to go to step 5 and divide the sum of squares, the 32, by the population size, 6. So there are 6 values. So our population variance is 32 divided by 6, which equals 5.33. And again, we're going to use the sigma square sign for population variance. So I'm going to talk a little bit about sum of squares versus the population variance. Now both are measures of variability, or you can call it spread. Okay, they both tell you how spread out the data is. there's a little difference. So the sum of squares is a measure of total variability or spread. It's a total squared variability. Versus the population variance, which is a measure of the average variability or spread. So it's the average squared variability.